Hello friends, welcome back to the bench. Our patient today is this beautiful Asus Prime Z370A, which, as described by the owner, or previous owner, doesn't post. Doesn't post can mean a lot of things, but what we do know is that it doesn't work. So, let's give it a quick diagnosis. When the seller, because I bought it on eBay, the seller said that you probably won't be able to fix this one, because it, yeah, what did he say? It doesn't post. So he did some testing around it. So if it was something simple, it would have fixed it. So this is not something simple. But as soon as I heard it doesn't post, meaning probably the LEDs are not lighting up, I immediately jumped to probably Super IO chip is faulty. So let's see if we can confirm that. I don't know what kind of testing has been done on it, but let's start with short finding. First, let's confirm that it's not going to explode once we connect. And now let me find the board view, so I don't have to remember. 3 volts. No short. Also 3 volts here. We good. 5 volts. This is fine, and this is fine. 5 volts standby. Well, I don't expect issues on standby because supposedly the LEDs are lighting up. It's fine. 12 volts positive. Here and here. We're good. Negative 12 volts. Second one from the bottom. It's fine. And PS on. Well, I would not expect any issues on PS on, but it's fine. Okay, so the board is safe to turn on. Oh, we forgot VCORE. VCORE. It's fine. It is fine. Now actually let's check the VCORE behind the transistors. It's fine. At least no shorts. We don't know if it's fine. We know there are no shorts. So that's number 1. So let's put on the CPU, and now the VCORE should show a lot lower resistance. There, it's almost short. Alright, but that's normal. If we switch to ohms, it should be around 3 ohms. Yeah. So this is fine. Now let's go to voltages. Let's connect just one connector. So we're not going to connect VCORE yet. Alright, so the CPU will not start. But what will happen is right now we'll confirm whether the EC chip is functioning, because without EC the board will not boot, which could also be considered not posting. If the board does turn on, if the Super IO is functioning, we're gonna see the CPU LED, red LED over here, indicating that the CPU is not present or not functioning. well, if the CPU is not present, the board will not, at least this board will not start. EC chip will not turn on the power because of no CPU. But if the VCORE is not connected, the board will boot and show the CPU failure. And actually, before we do that, let's just check the voltage on the battery, which is low but not super low. This is still rather acceptable. Some boards, very few, but some of them will not post if the battery is low. You'll see nothing on the screen. Some will just show the error message that the CMOS battery is low. It all depends on the board. Alright, let's turn it on. And indeed, the LEDs on the back are lighting up. The LEDs are controlled by this little driver over here, right behind the connector. Not important. And now let's do EC test. It started. The CPU obviously is not gonna heat up because the VCORE is not connected. But the LED, the CPU LED is not lighting up. So we are likely facing a faulty SIO. But before we jump there, let's do the test with VCORE present. So let's connect VCORE. Turn it on again. And did you hear the click? Yeah, it tried to boot and immediately turned off. Which could mean short on VCORE, but there is no short on VCORE. So it's likely a feedback, but there must be something wrong with VCORE since it's behaving that way. But it's the EC chip that turns off the power supply. So maybe it's not SIO after all. Let's check the if there was a short. There's not a lot of stuff over here. We have one coil over here which supplies all our transistors. We have 3 rails over here. Each rail uses 2 coils to produce VCORE. So any shorts on these or these high gate and low gate transistors, that would show up if we probe here, because yeah, they're connected right here. However, if the this one's high transistor, right? And MOSFET, yeah, this is high gate. So low gate, it's these, yeah, that's LG. And that's what shorts us to ground. There. This is N-type. And this is on the ground. These are, it's a source or this is drain. It doesn't say which one's drain, which one is source, but it doesn't really matter. So this, yeah. So this shorts us to ground. So if one of these is shorted, it would behave like this. But we don't know if the power supply is turning off or if the feedback is cutting off, right? As soon as it detects the 12 volts over here. I actually couldn't find how the feedback is connected. So maybe it's not a feedback issue. But that still doesn't explain why we don't see the CPU lit up over here. So even if there is a short on low transistor, we should still see the CPU light up over here, because right now it's not relevant. This is completely separate circuit. It's only supplied through this connector, the CPU connector. Well, let's try this. So let's first tackle what we can, because if the SIO is indeed faulty, which so far it's like 90% chance that it's the SIO that is faulty, we can replace it. They don't need to be programmed. However, depending on the case, when you replace the EC or SIO, you might need to clear the BIOS, one of the BIOS regions. It's definitely for PCH. If you replace the PCH, you do need to clear the region. But there's also EC region, and I think when you replace SIO, you might also need to clear the BIOS or play with the BIOS. But in that case, even if this was a BIOS issue, we would still expect to see these diodes flash or light up. So at this point, the CPU should light up, then you connect the VCORE, the memory should light up. Then you plug in the memory, and then VGA should light up. Actually on this one maybe not, because it has internal display adapter, so the VGA might not light up, but that's how you kind of eliminate, that's the process of elimination. So at this point what I want to do is set 12 volts on the power supply, and I want to see how much power is being grabbed from VCORE. Is it actually the issue of VCORE or not? Meaning if the low transistors, one of the low transistors is shorted. Because it's very possible. Now, to test that, let's... Oh, okay, yeah, okay, we have a short. Okay, so as soon as I put 12 volts over here, it's grabbing nonsense. Meaning I limited it to 500 milliamps, which should be fine at this point because it's not turning on. It should be fine, but it's grabbing everything. So let's connect the thermal imager and see what's going on. See if we can spot anything getting hot. Now for this, I would probably should remove the heatsink so I can see which one. But what I'm gonna do is start with this, because maybe it's the CPU that's gonna start heating up, which means I need to increase the... But no, now even if this, well, there's 3 ohms, right? But, okay, there's 3 ohms, fine, but it shouldn't start yet. It shouldn't, I think it shouldn't start. but maybe it should. Well, let's see. Let's turn it on again. Let's give it 1 amp and see what's gonna happen. Full 1 amp, and it's going somewhere. It's going somewhere where 1 amp, so that's 12 watts that we're trying to push, right? But yeah, so as I turn it on, our voltage drops to 67 millivolts, right? So that's a dead short, even though the meter doesn't tell us that it's a dead short, but it is. In which case, let's get rid of the heat sinks and inspect. This okay, we have liquid damage. That's what happened here. It's liquid damage. And okay, so we have our diagnosis. See all this? Looks like soda. It's definitely doesn't smell like anything. Maybe it's Coke. There. So VCORE is our issue. Now that we pushed some power through it, let's check again the voltage drop. And now we have a short. Yeah. So pushing energy revealed the short. Before it was not shorted. Yeah, and now it's a dead short on VCORE, which most likely resulted from liquid damage. I don't see, so far, I don't see signs of corrosion or oxidation. So you see, this short, it's a good tool to have. The voltage injection is a good process, because as you saw, there was no short on VCORE before, and when I connect the power supply, it immediately turns off, which normally means short, but the PSU is capable of detecting shorts relatively quickly, which means it's not gonna push energy into the board, which means it's not gonna cause any more damage. But when I inject the voltage, then I just limit it to whatever current I wanna limit it to, and if there is something on the verge of shorting, it will go dead short, just like here. Now, I am curious still what is going to get hot. So, let's connect this again, and let's see which transistor. Oh, nothing's heating up. That's weird. So the short must be really big, meaning it's capable of conducting a lot of energy. That is weird. Because the voltage drop is too high. And I don't want to push more than 12 watts. It's already way too much. But it's not actually 12 watts because it's that short. So we're pushing 1 amp at like 69 millivolts. Okay, so without the CPU, we have a lower current draw. So now I'm thinking, did I fry up the CPU? Could be that I fried it up. I probably shouldn't have connected 12 volts while the CPU was there. But the CPU was grabbing some power. The voltage actually never rised to the dangerous levels. So I think the CPU is fine. I would guess CPU is fine. But now let's get recording on the thermal imager and click, and we have 1, 2, 3. Okay, now let's turn it on, and there you go. That's our culprit. I don't know which one, but it is the bottom, as I suspected. And it looks like this one. This one here. So that is our problem. Let's see, what kind of transistor is it? That was easy. See? Challenge, as I said to the, as I told the seller, challenge accepted. At least I'll find out what's wrong with it. Even if I can't fix it, I will find out what's wrong with it. But in this case, I see what is wrong. And so this whole rail over here, these two coils, these two, this transistor, the higher one, this one here. Let's see the schematic again. Okay, so this is our transistor in question, the low transistor. That's why we couldn't see it before, because it's behind the high transistor. Right, that's why it wasn't shorting before. So this is this transistor and MOSFET, and let's see the driver. This is the driver for this rail, this is the driver for that rail. Okay, so the driver is NCP whatever, because I would think that the driver also could be faulty. It's a tiny chip over here, tiny little chip right here. So that's our driver. That's the, oh, hang on, you can't see anything because I'm not on camera. So this is our driver. This is our faulty transistor. And we have plenty of Coca-Cola here, or whatever. Yeah, look at all that. Well, the liquid damage caused the issue. For sure. Now let's confirm that we have 0 over here. Oh, it's a little higher than I expected, but could be because of the direction. Yeah, it's much higher than I expected. Well, this is the one that heats up. This one's fine. Yeah, this one's okay. The high ones. Oh, this one is a piece of wire, and this one is also a piece of wire. Huh. But on thermal imager, only this one heats up. Right? I'll review the footage because I don't remember now. But what the meter is telling me is that this is our shorted one. This one, well, it's not good. Oh, now it's... What is... No. Yeah, it's not good. It shouldn't be doing that. The gate is okay. So let's check the gate on this one. Yeah, gates are okay. So that's good. That means that probably our... Yeah, this one's fine. So most likely our driver IC is good if the gate is not shorted. Which is great news, because I don't know where to get this. I do know where to get this. But before we can fix this, first step is to clean it. For this, to clean this, because I expect this is a sweet liquid. To clean this, you need to use 70% isopropyl, not 99%. That 30% water will perfectly dissolve sugar, and the alcohol will do the rest. Step number 2, I will get rid of all 4 of these transistors. I will desolder all 4 of them. And these are all N-type. I do not have these in stock. But I might have... I have some over here, but they're not exactly the same. And I don't have schematics for this board, which means I don't know if these are N-type or P-type. They are most likely N-type, but we don't know. So, step number 2, find the replacement. And I might actually just order transistors from DigiKey or Mouser and just replace them with new ones. That will likely be the route I'll take. But one last thing. Even with this damage to VCORE, we should still see the SIO saying that the CPU is not detected. This should still be the case. So, since VCORE is completely isolated from the rest, it only supplies CPU, and I don't even see any feedback. If SIO was functioning, it would ignore this whole damage here and still say that the CPU is not detected. If it doesn't do that, then I expect SIO is indeed faulty, and the fault could appear because of the liquid damage. So 12 volts from the VCORE, connector here, could short over to the SIO, and SIO is fried or otherwise faulty. So it's a tough one. This one is a indeed tough one. However, you can see how easy this was to find the fault, at least the fault that we can pinpoint. Even without the thermal imager, you just take off the heatsink and you see that there's a extensive liquid damage. And then probing transistors with the multimeter, you can find which ones are shorted. And even if not, even if you're not sure which one is actually shorted, just replace them all. They're not very expensive. These are, well, maybe 50 cents per transistor, up to like maybe $5 for, no, $5 are these big ones, power transistors. This is technically power transistor, power MOSFET, and it pushes hefty amount of energy through it. Hefty amount of current, because the CPU requires roughly around 1 volt, and you're supplying with 12 volts, and this is maybe 60 watts. So at the level of 1 volt, that's a lot of current. That's why we have so many rails, right? Because one rail would not be capable of delivering this much current. But that is our diagnosis. So maybe I haven't fixed it yet, but it's a good candidate for fixing. And as you can see, sometimes all you need is your own eyes to diagnose it. You don't need fancy equipment sometimes, but it always helps. It always helps to have fancy equipment. You can do stuff that or you can have a little less experience, a little less skill. If you make up with the with tools, you can still be pretty effective. Anyways, this is our diagnosis of Prime Z370A. Thank you guys very much for watching, and I shall see you in the next one.